Hello, this is Mr. Jolt here, and welcome to today's maths lesson on geometry. And we're dealing with congruence today. Now, I want you to imagine that you've got a couple of different shapes here. So there's one shape. That is a perfect square, right? It's a perfect square. Now, squares are interesting because all sides are the same. So let's say that all of these sides have length x. So they're all the same because they're a square. Now, let's say that you have another square that's also obviously a square, so it's exactly the same proportions of this, but it has a different length here, y. And then let's say that you have another square, but let's just kind of rotate it slightly, and let's give it exactly the same length of sides, x. Now, what we've got here are some shapes that we can use to talk about two different kind of expressions that are important in today's lesson. One of those words is congruence, the other is similarity. And one of these shapes is similar to this square, and the other one is congruent with that square. Now, what's the difference? Well, if a shape is congruent, it is exactly the same shape, and I mean exactly the same. It might be rotated, it can even be reflected, but we're dealing with exactly the same shape, exactly the same angles, exactly the same lengths. So, based on that definition, this shape is congruent with that shape because they are both exactly the same. That one's been rotated though. So, this shape is congruent. Now, shapes which have the same proportions and all the same angles and stuff, they're described as similar. Now, this square is obviously not the same square as that one. It's not congruent with that square. It is, however, similar because all of the angles are the same. In a square, all of the edges, all the corners here are at right angles. And again, all the corners here are at right angles. The difference is the length of the sides, but everything else about this square is the same. The right angles are the same, the proportions are the same, and so we describe this as being similar. And these are the two phrases which are going to be important today. We're going to be focusing mainly on this one, but it's also important that you know the definition of similar as well. Now, squares seem pretty simple, so let's deal with something else, shall we? Let's have a triangle instead. So here we have a scalene triangle. There's my triangle right there. And we're just going to do that just so you can kind of see the differences there. So there's my scalene triangle. Now, if I were to draw a similar scalene triangle to this, then it wouldn't matter if the sides were a little bit larger, as long as all of the angles in the triangle were the same. So we're dealing with the same shape, just bigger or smaller. So again, this angle's the same as that one, this angle's the same as that one, and this angle is the same as that angle there. All right? The sides are not the same length. The sides are different lengths. This one might be x. This might be 2x. This might be y. This might be 2y. This might be z. This one might be 2z. You notice I just put that there. It's the European z because it just makes it easier to tell the difference between that and my 2's, which are terrible. And so again, this triangle here is similar to that one because it has got the same angles in all of the corners. And the sides are all kind of in proportion. Now let's say that this triangle weren't 2. Let's say that this one was 3x, and so this side here is 3 times that side, but this side is still 2 and 2. That would no longer be similar. That would just be plain different. But let's say that for the moment it is similar because all of these sides are in proportion. Now if I were to draw a congruent triangle, it would have to be exactly the same as this triangle. Now remember, I could rotate it if I wanted to. I could rotate it. I could even reflect it. But the important thing is that all the sides are the same length. So all the sides are the same length there, and all the angles are the same length as well. And that's the difference. So congruence just means exactly the same, apart from being maybe rotated or reflected. And similar means the same angles and proportions, but a different size. And that's what those two phrases mean. So, as we normally do, let's go to my website now and let's just see what we can find to help us to kind of revise that and think about it a little bit more. So let's go to geometry and measures here. We go down to here, congruence, similarity and transformations, and congruence, similar. I'm going to give these proper titles at some point, but for now it'll do. All right then, so we've got Madonna says that congruent shapes can be rotated or reflected. Oh, dear me, spelling mistake, I have to work on that. Is this statement correct or incorrect? Well, congruent shapes can be rotated or reflected, so the answer to that is going to be correct. Let's have another one. Generate one more. Donald Trump says that in a congruent shape, all angles are the same, but sides are different lengths. Is that statement correct or incorrect? Well, if we go back to our example here, we can see that actually in a congruent shape, the sides have to be the same length as well. So congruent, congruent. So that statement is going to be incorrect, I hope. There we go, fantastic. Madonna again, man, it's all about Madonna today for some reason. Says that neither congruent nor similar shapes should be reflected or could be reflected or rotated. Is the statement correct or incorrect? That's incorrect. So I have one more. An unwilling Kung Fu student says that similar means the same shape but a different size. Is the statement correct or incorrect? And the answer to that is, of course, correct. Now, what I want to focus today is on congruence, mainly. So let's just think about what this means in terms of triangles, because obviously, you know, pretty much any regular shape that has the same length of sides is going to be congruent. But in exams, for some reason or another, I like to focus on triangles. Once again, if you're in year 11 right now, your school is over thanks to coronavirus, and you're going to be assessed in different ways. But if you're in years 9 or 10, this is going to be important for you. So year 9 or 10 age. So let's take a triangle right here. Similar triangle to before. Let's say we've got X, Y, and Z sides again. And then let's just have A, B, and C as our angles here. Now, how can we tell if a triangle is congruent? Well, there are actually 4 different rule sets. There are 4 different rules that we can use to tell us whether a triangle is congruent with another triangle or not. Because if you rotate a triangle a little bit and kind of reflect it or something, it can start to look quite different. And so ideally, you'd like some kind of a way or a mode of telling if a triangle is actually the same triangle or not. So there are actually 4 different rules that you can have to help you to work out if a triangle is congruent. Now, the first of these rules is known as SSS. Just checking you can actually see this, SSS. And what this rule means is that in a triangle, if you've got all 3 sides are the same length, then you know that that triangle is congruent with another triangle. So let's say we have another triangle right here. We don't know any of the angles, but we do know that this side is length X, Y, and Z, the same as that triangle. And so we could substitute numbers in there if we wanted to. If that side was 2, 3, and 2.5, that's the hypotenuse actually, so that's be 2, 3, and 2.5. And this had exactly the same length of sides, we would know that they were congruent, all right? So these are congruent triangles. Now, the next rule is AAS. And in triangles, we have sides, we also have angles, and that's what A stands for. If you have a triangle where you have 2 angles and a corresponding side, and we'll talk about what that means, which are the same, then we know it's congruent as well. So let's draw out another triangle. That's referring to that one up there, by the way. Now, and let's say that we have angle A, angle B, and side Y. If these are the same as that, just from these 2 angles and this length of side, then we know that that triangle is going to be congruent with that triangle. Now, this is kind of important because it's got to be a corresponding side as opposed to the angle in between. Because if your angle in between is, I suppose, can it? Oh, who knows? Who knows? Anyway, let's just stick with that for now. The next rule is SAS. SAS, not the Special Air Service, but if 2 sides and the angle in between those sides are known, that is another way you can tell if a triangle is congruent or not. So again, let's have 2 sides. Let's have Y and Z, and the angle in between these 2 sides, C. If these 3 match up, then again you know that it's congruent with that. So you need 2 sides. Could be any 2 sides. We can have X and Y with B if we wanted to as well. That would be another way of telling that this triangle is congruent. Or we could even have X and Z along with A, and then we know that triangle is congruent. All right. So that's our third rule. And the final rule for telling if a triangle is congruent is if it has a right angle, the hypotenuse and one other side which matches up. So we call this, right, RH and one more side, so RHS. So in this case, this one only works for right angled triangles, all right? So let's do a completely different example here. There's our right angled triangle. There's our right angle, we know what that is. And then we can have A, B, and let's have P, Q, and R be the length of our sides this time. So, in order for a triangle to be congruent with this one, so in other words, to be the same as that one, in a right angled triangle, P would need to be the same because it's the hypotenuse. It's got a right angle as well. And then finally, we need one more side to match up. So that side in this case, if Q were the same as Q, or if R were the same as R, then we would know that that triangle is the same. All right, so these are the 4 rules that you can use to tell whether or not a triangle is congruent. And only one of these conditions has got to be met. Only one of these rules has got to be met. Let's go back to the website now, not my building of the website, but the website itself. And let's take a look at a few of these. What do we got here? There we go. Right, so congruent means the same shape and size. An unwilling Kung Fu student says that 2 triangles are congruent if all 3 sides are the same. Is that true? Well, yes, that's one of the rules. If all 3 of the sides are the same in a triangle, then you know that triangle is congruent. So the answer to that is going to be, that's correct. Let's have another one. Stalin says that 2 triangles are congruent if 2 sides are the same. Is this statement correct or incorrect? Well, if 2 sides are the same, but we don't know anything about any of the angles there, so 2 of the sides, yes, have got to be the same, but we need to know an angle there as well. Otherwise, it won't necessarily be congruent. So the answer to that is that this statement is incorrect. Let's just take one more. An intelligent gorilla says that 2 triangles are congruent if all 3 angles match up. Is this statement correct or incorrect? Well, in a congruent triangle, all 3 angles will match up. However, do you remember what we were saying about similarity earlier? If I wanted to, I could have a triangle which has the same angles, A, B, and C, as this one. But if all the sides are smaller, then that triangle will not, in fact, be congruent. So the answer to that is that it's incorrect. Let's take a look at something slightly different. The triangles above are congruent. What condition proves this is the case? Man, okay, so this is... oh, there we go, it is working. All right, that's interesting. So the triangles above are congruent. What condition proves that this is the case? Well, we can see that all 3 sides are the same, so it's the all 3 sides are the same rule. The 3 sides are the same, SSS. Let's have another one. The triangles above are congruent. What condition proves that this is the case? Again, we've got this SSS thing going on, so it's because all 3 sides are the same. Are these really the only 2 we've got? Oh, there we go. There are some more. The triangles above are congruent. What proves this is the case? Well, do you remember what we were saying about the right angles here? So it's the RHS rule right there. So what we've got here is a right angle, we've got a hypotenuse, and we've got another side there. So it's the RHS rule. Take a look at another one, see if I can work out which of these types are incorrect. Now this is... Ooh, okay, so I'm going to have to go back and fix that at some point. I'm not sure what's up with that. The triangles above are congruent. What condition proves this is the case? Well, in this case, it's going to be the angle side rule. So you've got your AAS rule there. It's going to prove that's the case. So there you go, AAS. And let's take one more. If I just click here, I should be able to work out actually which of these has a problem if it pops up again for me. There we go. So the problem is with the SAS triangle, so I can go back and correct that later. Anywho, that was my lesson on congruence right there, and I hope you've got an idea about what it means for a shape to be congruent. In other words, if a shape is congruent, it means that it is exactly the same as another shape, albeit it may be rotated or it may be reflected. It is still congruent if all sides and angles in the shape are the same. Thanks very much for watching. This is Mr. Jolt signing off. Clickety, clickety, click.